Dear students, good morning. Previously, in the two videos, we discussed about the matrix. In the first video, part 1, matrix definition and order of matrix, rows, columns, everything is taught in that matrix, part 1, that video. The second video, this is third video. The second video, that is types of matrices. In the types of matrices, row matrix, column matrix, square matrix, diagonal matrix, scalar matrix, and identity matrix. All the types of matrices with examples you have to learn it. Simply in 1 mark bit or 2 mark question, define a square matrix, define a scalar matrix, like that the question will be asked. Okay now? So in the first and two videos I taught the theory part. Here also the two topics are there, two definitions. It is also under the types of matrix. This is zero matrix, or it is called as a null matrix. Null means zero, empty. Okay, you see, all the elements of a matrix are zeros. Then the matrix is called a null matrix or a zero matrix. It is generally denoted by O. 0, 0, 0, 0. All the elements contained in the matrix are zeros. It is 2 by 2 matrix. It is not needed in the zero matrix, a square matrix. All types of matrices. A row matrix is there, column matrix may be. Here 2 by 2 square matrix. Here 2 by 3 a rectangular matrix. It is a row, or other is a column, like this also, may also. It is 0, 0, 0. It is also a zero matrix. Okay now? Here it is 3 by 1. Don't think it is a row matrix or it is a square matrix, it is a rectangular matrix, it is a column matrix. That is a different one. According to the size or order, we may call it as, but especially all elements are all zeros. So it is a zero matrix or a null matrix. Okay now? Whereas the last definition, equality of matrix or equal matrices. If two matrices A, capital A, it is a notation. Capital A, Aij. Capital A is a notation for matrix. Small Aij is an element. It is a general element contained in the box of the matrix. Aij, an element. I thrown already in the general matrix we discussed about that one. This is element, this is a matrix. This is first matrix and it is a second matrix. It is B is equal to Bij. Are said to be called as equal matrix. They are called as equal matrix. Here it is said to be. They are said to be called. It is called to note it. It's said to be called as equal matrices. Then there are two conditions. One is their orders. Order of the matrix is there. Yeah. The order of the two matrices must be equal. It must be equal. Suppose this is m by n. It also m by n. Means it is 3 by 2 means it must be 3 by 2. It is 2 by 3, it is also 2 by 3. It is 1 by 3, it is also 1 by 3, like this. And the second condition is the corresponding elements. Corresponding elements of the two matrices should be the same. That means the elements Aij, Bij. Aij, the element in the capital A first matrix, Bij is the second. So all the corresponding elements must be same. And the order is, here order is 2 by 2. That must be equal. In the example I am taking. This is A. Capital A is first matrix A, B, C, D. Capital B is 1, 2, 3, 4. If they are equal means, you see, order is the same. Then A is equal to 1, corresponding element. The position of small a in the matrix capital A, first matrix is 1, 1, first row, first column. Here also, the first element 1. B, it is 1, 2, first row, second column. It is equal to, here first row, second column is 2. Here is D is equal to 4. C is equal to 3. Like that. So A is equal to 1, B is equal to 2, C is equal to 3, D is equal to 4. If capital A is equal to B, if the two matrices are equal, we may make the equality of the corresponding elements. So small a is equal to 1, small b is equal to 2, c is equal to 3, d is equal to 4. Okay now? Very simple. Simply you have to take it. Two matrices are said to be equal. Two or more also. Their corresponding elements must be same and order also equal. Okay na? That is the definition, the two definitions. Okay na? Pass. Yeah. Okay na? We discussed all the types of matrices and definition. Equality of matrix also is defined well. Now we go to solve the exercise 3.1. You see, here the first one, in the matrix capital A, the first one, capital A is equal to, it is 2, 5, 19, minus 7. 35 minus 2, 5 by 2, 12. It is root 3, 1, minus 5, 7. Okay now? It is a given matrix. And we are asked, write down the order of the matrix. We are asked the order of the matrix. By definition, what is the order of the matrix? Number of rows and number of columns. You see, here order of the matrix. Order of the matrix A is equal. Number of rows 1, this is 2, this is 3. So 3 into. But we have to spell as we have to read as 3 by. And number of columns 1, 2, 3 and 4. So the order of the matrix is 3 by 4. So first question is okay. And the number of elements, we are asked to find the number of elements. The number of elements is here 3 rows into 4. How many? 12 elements are there. Okay na? Here the number of elements in the matrix means, here it is a number of rows into number of columns. The number of rows, that number and number of columns are to be multiplied so that we get the number of elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 11, 12. Okay na? So these are 12 elements. How it is obtained? 3 rows into 4 columns. Here it is a multiplication, of course. We are in finding the number of elements, but order. If you mention the order, you have to spell, you have to read as 3 by 4. That means 3 rows with by 4 columns. That is okay. But in order to find the number of elements means 3 into 4, that is 12 elements. Now, next we are asked to identify the element position. You see, A13, that means first row and third column. It is the first row and third column. Okay, na? First row, third column element. First row, third column. It is row 1 and third column is 19. So, A13 is 19. A21, it is a second row. It is a second row, but first column. Second row, first column means second row, first column. So this is a 35. Similarly, A33, not say it is A33, A33, 2 digits are there. A33, third row, and it is a third column. Okay, no? Third row and third column. It is third row and third column. 1, 2, 3, third column, third row is -5. A24. A24 means it is a second row and fourth column. Okay, now second row, fourth column is 12. Okay, now is it clear? And at last is A23, second row and third column. Third column. You see, second row and third column. This is 5 by 2. Okay, now like that, the order of the matrix, number of elements, and the position of elements. What are the element position? We are given position of element and we are identifying that element. So this is a good question, good problem. Okay, now, yeah. Next. Next, third one. If a matrix has 24 elements, what are the possible orders it can take? It can have. You see, suppose given, what is given here? A is equal to Aij, it is something m by n, number of elements. How much? M into n is equal to 24 elements are there. Just now we find the number of elements. It is number of elements. Just we are taking A is equal to m by n. M into n. Here it is m by n. Here it is the number of elements means m into n. We multiply the number of rows by the number of columns. Is 24 elements is given. You see that it is 1 into 24 first. Or it is 24. Or 24 into 1 is equal to 24. 12 into 2 24. 2 into 12 24. 3 into 8 24. 8 into 3 24. 6 into 4 24. 4 into 6 24. Is there anything is there? You see, we have to find the factors. You see, 6 4 24. 4 6. Here 6 means 6 rows 4 columns. 4 rows 6 columns. 3 rows 8 columns. 8 rows 3 columns. 12 rows 1 column. 1 row 24 columns. Here is 24 rows, 1 column, one row, 24 columns. Here it is 12 rows, 2 columns. 2 rows, 12 columns, 24. Like, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So, we have the possible matrices, different matrices which containing 24 elements is for this question. What are the possible orders? What are these are the possible? Or it is possible orders of given matrix whose number of elements 24. If a matrix containing 24 number of elements, then the possible order, that is the 8 different types. Okay, na? That is the thing. What are the possible order of? How many orders are there? 8 different types are there. 8 different orders are there. Those orders are like that one. Okay, na? That is. Next question in that one. If it has 13 elements, suppose A is equal to A, it is m by n. Here m by n is equal to 13 only. We are given the 13. You see that here 1 into 13 or 13 into 1. It is a prime number. The factor is itself, by itself, and 1 is common. So there are only 2 different matrices whose orders 1 into 13, 1 by 13 or 13 by 1, and whose number of elements is 13. Okay, na? Very clearly we solve it. Okay, na? That is the thing. Now we go to third problem. Third problem. If a matrix has 18 elements, what are the possible order it has? Same question here also. And if it is having 5 elements, it is the next question. So let capital A is equal to A is a m by n by given. What is given? Number of elements is equal to how much? M into N, number of rows into number of columns. When we are finding the number of elements, is equal to 18. So different types of it is different orders are 1 into 18 first. 18 into 1 2 into 9, 9 into 2 3 into 6, 6 into 3 Anybody? Anything is there? 2 9s 18, 9 2s 18, 3 6 18, 6 3s 18, 1 into 18, 18 into 1. So how many are there orders? 1 2 3 4 5 6. There are 6. There are 6 different order of matrices. That means 6 different matrices which are containing the number of elements 18. That is the thing. Okay, na? Those orders are 1 by 18 or 18 by 1, 2 by 9 or 9 by 2, 3 by 6 or 6 by 3. Okay. If this A is equal to A is m by n, If that it has number of elements, you write it. Number of elements is equal to 5. Suppose not 18, 5 elements. Means m by n, m into n is 1 into 5 or 5 into 1 only, because it is a prime number. In the previous problem also 13 were given. Here also 1 into 13, 13 into 1, like that we wrote. So here also 1 into 5, 5 into 1. Only there are 2 types. Okay, na? 2 types of matrices whose number of elements is equal to 5. Okay, na? So these are the solution. Like that we have to solve. Okay, na? Yeah. Okay. Now we are going to solve the fourth problem. You see that I am observing 4 and 5 are important problems. This type of problem is given as example and already we discussed it. You see, we have to construct a new matrix, 2 by 2 matrix, whose order is 2 by 2. And here it is a 3 by 4 matrix. These two are important, don't neglect. It is dated. Dated means already it is asked in the exam. Okay, na? Right. By given means what is given in the problem, the data. You say we have to construct a matrix A, I, J, it is 2 by 2, only 2 by 2. Okay, na? That means here I is equal to 1 comma 2 and J is 1 comma 2, here also 1 comma 2. The first question in that one, A I J is equal to I plus J whole square by 2. You see, here the element is how the element means the number inclined in that matrix. That number, that element is some relation with their position. Position means that the element where it is situated, where it is means in the matrix, first ith row and jth column. So that element, that number is also connected with, related with their position I, J. Okay, na? You see, A 1 1 means I is 1, J is 1. 1 plus 1 whole square by 2. It is 2 square 4 by 2 means 2. So the first element is 2. A 1 2. I is 1, J is 2 whole square by 2. The same by 2 square is same. Instead of Ij, first problem 1 plus 1. Here 1 plus 2. It is 3 square is 9. 9 by 2. That is the second element. Is there 1 3? 1 3 is there? No. Because J3 not there. Only 1 2. So it is not possible. First row, first column. First row, second column. Anyway. Next. First, second row, first column. This is 2 plus 1 square by 2. It is also 9 by 2. Okay now? According to the first digit and second digit. First digit is always I. Second digit is always J. You remember? Next, A22. A22 means second row, second column. I is 2, J is also 2. So 2 plus 2 square by 2, 4 square, 16 by 2 means it is 8. So here relatedly, capital A is equal to 2 by 2 matrix. Already it is mentioned, we have to construct whose order is 2 by 2. So first is 2. The second element according to the position, don't forget, it is 9 by 2. And this one, A21 means here, it is also 9 by 2. And A22 is 8. Okay, na? Like that we have to construct the problem, the matrix. Okay, Nana? Is it clear? I can solve all the problems. Okay, we go to the second one, the fourth question, but the second problem. Yeah, here also it is I by j. It is defined as I by j. Here also I is equal to 1 or 2, j is equal to 1 or 2. So A11 means I is 1, j is 1, we get 1. A12, I is 1, j is 2, 1 by 2. A21, listen, A11, first column. I is 1, first digit is I, second digit is j. I is by j, 1 by 1, 1. Here also 1 by 2, 1 by 2. Here it is 2 by 1, it is 2, 1. Okay, na? You following? Next, the last element is A22, means 2 by 2 is 1. Here the required matrix with the condition 2 by 2, A is equal to, it is 2 by 2. Okay, the first element 1, second element is 2. And it is 2 and it is 1. Okay, na? Is it clear? Yeah. It is the third one. A is I plus 2j whole square by 2. I think I plus 2j whole square by 2 is the one. Here also I is equal to 1 or 2. J is equal to 1 or 2. It is according to the 2 by 2 matrix. Okay, na? Like this. So it is A11, first element. That is 1 plus 2 into 1 whole square by 2. 1 plus 2, 3. 3 square is 9 by 2. A12, 1 plus 2 into 2 square by 2. 2 into 2, 4. 4 plus 1, 5. 5 square is equal to 25 by 2. A21, A11, A12, A13 is not there. A21. It is 2 plus 2 into 1 whole square by 2. It is 2 plus 2, 4 square is 16 by 2 is 8. And the last A22. I is 2 in this one. Plus 2 into j is also 2. Okay, na? Whole square by 2. 2 is 4, 4 plus 2, 6. 6 square is 36 by 2 is nothing but 18. Okay, na? So the required matrix is capital A is equal to, it is also 2 by 2 matrix. Okay, na? 2 by 2 matrix. So the first element is 9 by 2. Second element is 25 by 2. Second element means you go on a row, first row. Row 1, first element, second element, third element, like that. Next, this is row 2, A21, A22. Here it is 8 and it is 18. Okay, na? Like this, I have to prove. Next, fifth one. Here also, construct a new matrix whose size is 3 by 4. Means whose order 3 rows and 4 columns. It's a different one. Okay. Here two problems are given. Fifth one. Required matrix is capital A is equal to Aij. It is 3 by 4 matrix. It is given in the problem. In that problem, fourth problem 2 by 2. Here it is 3 by 4 matrix. Okay now. That means I is equal to 1, 2, 3. Whereas J is equal to 1, 2, 3, 4. It is of some different one. First, Aij is equal to 1 by 2 mod of minus 3i plus j is there. Minus 3i plus j. It is a modulus 1 by 2. It is 1 by 2. You see that? Here we write 1, 1, the first element. Ij, okay. It is defined like this, the first problem. Aij is defined like this in the previous problem. That means the element in this required matrix is connected, is related with the I and j. Okay, 1 by 2. I is equal to 1 plus j is also 1. So it is 1 by 2 minus 3 plus 1, that is minus 2. So it is 1 by 2 into 2, j is equal to 1 only. The very first element is 1. Next, A1, 2. Okay, now we are in the first row. I is always 1. Here j is 1, here j is 2. It is 1 by 2 minus 3 2. I is 1 plus j is 2. It is 1 by 2. You see, it is minus 3 plus 2. It is minus 1. So it is 1 by 2. Modulus is there. You see, it's simply 1 by 2. A1, 3. It is 1 by 2 with modulus minus 3 into 1 plus 3. Okay, now it is 1 by 2 into 0. This is 0. Minus 3 plus 3 cancels 0. Here j is 3. I is only 1. Is there any 4? Yeah, 4 is there. Because j is related with the column 4. So A4, A1 4 is 1 by 2 minus 3 into 1 plus 4. It is 1 by 2, 1. It is also 1 by 2. Minus 3 plus 4 then 1. 1. Modulus of 1 is 1. 1 by 2 is there. Yeah, it is okay. So in the first row there are 4 elements are there. Okay now? It is right. Just I will erase this one. Okay now? I want to solve here. This is a 2 1. The very first element, the second row. It is 1 by 2 with modulus minus 3 into 2. Here I is 2 and j is 1. It is 1 by 2 minus 6 plus 1. It is minus 5 actually, but modulus is there. It is 5 by 2. Okay now? Like this. Again, A2 2. A2 2. Okay now? A2 2 means it is 1 by 2 with modulus minus 3 of 2 plus 2. Here it is, in this case, j is 1. In this case, j is 2. R is always 2 only. So it is 1 by 2 minus 6 plus 2 minus 4. Minus 4 means here it is 2 only. Plus 4 by 2 is 2 only. Okay now, like this. Here also you solve this problem with your own effort, homework. Okay now? Right. Now, it is a 2, 3. 1 by 2 minus 3 into 2 plus 3. It is 1 by 2 minus 6 plus 3 is minus 3. Even though it is a plus. It is a minus 3. Modulus is there. It is a plus. Again, yeah, 2, 4 is there. Because j is related with the 1, 2, 3 and 4 also there. So it is 1 by 2 minus 3 into 2 plus 4. So how much? Minus 6 plus 4 is 2. 2 by 2 is 1 over. Okay now? And again, I will write it as well. Next, A 3 1. A 3 1. Because I is related with 1, 2 and 3. Because 3 elements are there, 3 rows are there. So I 3 1 is 1 by 2 minus 3 into 1, not 1, 3 then, plus 1. It is minus 9 plus 1 minus 8 by 2. With modulus is there. 8 by 2 is 4. Yeah, 3 2. Yeah, 3 2 is 1 by 2 minus 3 into 3 plus 2. 2 is there. 2. J is 2. So minus 9 plus 2 minus 7 by 2. It is plus 7 by 2 because modulus is there. Yeah, 3 3. 1 by 2 with modulus minus 3 into 3 plus 3 again. Why? Because j is here 3. Minus 3 into 3, 9. Minus 9 plus 3 is 6. Minus 6 by 2 is again 3 only, not minus 3. Because modulus is there. A 3 4. A 3 4 means 1 by 2. Modulus minus 3 into 4. 3 into 3 plus 4. It is minus 9 plus 4 is minus 5 by 2. Modulus is 5. Okay now? Is it clear? While solving this problem, we may commit so many arithmetic mistakes. Please try to understand and slowly you have to practice it well. So, I will erase and write that here. Observe it. Here, the required matrix. The required matrix is capital A is it is a large one. We are asked there it is 3 by 4. 3 rows and 4 columns. Okay now? Here you see a set of 3 elements A11, A12, A13. These 3 elements you see in the first row 1. It is 1 by 2 and it is 0. Here also there are not only 3 elements, 1, 2, 3, 4 elements related with the first row A11, A12, A13, A14. First row 4 columns, 4 elements are there. 1 by 2, 0 and 1 by 2. Don't confuse. And there also it is a related 2, 2, 2, 2 in the place of I. So second row and columns are changed 1, 2, 3, 4. So 5 by 2, 2 and 3 by 2, the last is 1. Again there it is 4, 7 by 2, 3 and the last is 5 by 2. Okay now? Okay now? Is it clear? Slowly 1 or 2 times, 3 times you have to practice it. The practice makes man perfect. Otherwise it will not be clear for you. Okay na? Try to understand. While you are writing out like this, you observe these 4 elements related with the row 1. That 4 elements related with the second row. And the last 4 elements are related with the last row, that is the third row. Okay, na? That is the problem. Yeah, pass. Okay. The sixth problem. Find the values of x, y, z from the following. You see. Okay. The sixth problem. Find the values of x, y, z from the following equations. It is an equation. Here a set of numbers. You see in this problem. First problem, 4, 3, x, 5 is equal to is there. So here in the question, equation is given. In this given equations, we have to find the x, y, z. It's a simple problem. You see in the first one, given, it is given, what is given? You see, 4, 3, x, 5 is equal to y, z, 1, 5. It is a 2 by 2 matrix. It is also 2 by 2 matrix. Already in the types of matrices we discussed. I taught you that equality of matrix are matrix equation. Equal matrices. But the condition is the corresponding elements. You see, these are corresponding elements. 4 related with y, 3 related with z, x related with 1, 5 is same. And the order of the matrices are same. So, by using that concept, 4 is equal to y, first one. And 3 is equal to z, x is equal to 1, 5 is equal to 5, yes, correct, 5 is 5, okay. Therefore, x is equal to 1, y is equal to 4, z is equal to 3. Okay, now? Why? Because in this equation, two matrices are made equal. That is given. The next, second one. Here also, x plus y, first element, 2, 5 plus z, and x is to y. It is 6 to 5, 8. Here also it is a 2 by 2 matrix. It is a 2 by 2 matrix. The order of the two matrices are equal, yeah. Because they are equal matrix, the corresponding elements must be equal. So x plus y is equal to 6. And 2 is equal to 2, yeah, okay. 5 plus z is equal to 5. So z is equal to 0. It is okay. Here x, y is equal to, you see that x, y corresponding element is 8. Okay, na? So we use here x plus y is equal to 6. What is y? 6 minus x. So here we use instead of y this 6 minus x is equal to 8. I'll go to the, observe here. X of 6 minus x is equal to 8. That is 6x minus x. X square is equal to 8. That implies x square. Here 0 remains. It is x square minus 6x plus 8 is equal to 0. But you write it as x square minus 6x plus 8 is equal to 0. It is a factorizing method. X minus 2 of x minus 4 is equal to 0. X is x square minus 4x minus 2x minus 6x minus 2 into minus 4 is 8. So it is factorized. Here x minus 2 is equal to 0, x minus 4 is equal to 0. So x is equal to 2 and x is equal to 4. Okay now? Is it clear? So, but one more thing. You see, which number we have to take? Whatever it may be now. Here, if y is equal, here x is equal to 2 now. If x is equal to 2, y is equal to 6 minus x. 6 minus 2, it is 4. So y is here 4. If x is equal to 4, y is equal to 6 minus x means 6 minus 4 means it is 2. Here y is equal to 2. Okay na? If you take x is equal to 2 in this example, you verify it. X plus y, 2 is 2, okay. X, y, 4 plus 2. If you take x is equal to 2, y is equal to 4 in that person. 2 plus 4, 6, okay. Or x4 in that case, 4 plus 2, again 6, okay. 4 2s, 2 4s, again 8, okay. So that is the answer. Okay na? Like that. X z 0, x 2 and y. I will write here. You see, observe me. Na? Hence, you see, x 2, then automatically y 4, z is equal to 0. Here z is equal to 0 is the constant. Or x4 or otherwise x4 y2 z is equal to 0. Okay na? Like that I have to solve. I think the last problem is there. It is we are given x plus y plus z. X plus z is there, and y plus z, okay now, is equal to, it is 9 5 7, okay now. Here is the erased, okay, it's correct. Now you see, x plus y plus z is equal to 9, corresponding elements. It is 3 into 1, here also 3 into 1. 3 by 1, 3 by 1 order. Corresponding elements I am taking. And x plus z is equal to 5. And y plus z is equal to 7. Okay, Nana? You add these two. 7 it is 2, it is 3, to 1. Okay, now? How can you solve it? We know x plus z is equal to 5. Here is substitute. Into 1. X plus y plus z is equal to 9. Okay. You write x plus z plus y is equal to 9. Is it okay? I am taking in some order. What is x plus z? 5 plus y is equal to 9. Because by using the second one, here we are using the second equation, x plus y, 5 plus y, this is 5, by using the second, then it is 9 minus 5 is 4. So, y value, the first, we get the y value. Again, x plus y plus z is equal to 9. X plus y plus z, put it in one bracket. It is x plus 7. 7 by using the third equation, 9. So x is equal to 2. Okay, now again in this x plus z is equal to 5, you substitute x plus what is x value is 2, we know it. It is z is equal to 5. That means z is equal to how much? 5 minus 2 is 3. It's very clearly 3. Therefore, what are the values of x, y, z? Therefore, is okay. That is the sixth problem. The third Roman. Third problem is therefore x is equal to how much? X is equal to 2 and y is equal to 4. Z is equal to 3. Okay, then. That is related with the third problem. This is the second problem. Okay, na? Right. Okay. 6 problems solved. 7th is again given homework. You try to solve it. And 8th, 9, 10. These are objective type questions. While given Aij, a matrix notation, which is a square matrix. Here it is mentioned square matrix. This is square matrix. Then m is less than n, m is greater than n, m is equal to n. Square matrix means the number of rows and the number of columns must be equal. So this is correct, we know it. If any equation is there, number of rows less than or greater than number of columns, then it is a rectangular matrix. Here it is equal to. So it is a C option. Clear? Yeah. By definition, it can be solved. Here you see, it is a different one. By given values, what given values of x and y, it will make a pair is equal. These two matrices are equal. By given, you see, I will write here, it is equal. We are given equal. Through that one, you see here 3x plus 7 is equal to related. Corresponding element is 3x plus 7 is equal to 0. 3x is equal to minus 7. X is equal to minus 7 by 3. Again, we may say this one also. It is 2 minus 3x is equal to 4. 2 minus 4 is equal to 3x. Minus 2 is equal to 3x. X is equal to minus 2 by 3. At one place in the same problem, at one place x is equal to minus 7 by 3. Here it is minus 2 by 3. Not possible. So it is wrong. Even in the case of y also is said, you see, y minus 2 is equal to 5, y is equal to 7. Here it is 7. Whereas in this case, you see, it is y plus 1 is equal to 8. So y is equal to 8 minus 1, 7. Of course, y is the same. But in the case of x, it is not possible. So here, you see, not possible is correct. Okay, Nana? So B option is correct. Now, the last one, 10th problem. Observe it. The 10th problem is a different one, the last problem. The number of all possible matrices of order 3 by 3 with each entry 0 or 1. It's a fantastic concept. You see, here observe me, a very good concept. 10th problem. A is equal to, it is a 3 by 3 matrix. So there are 3 elements in the first row, 3 elements in second row, and 3 elements in the third row. There are 9 elements. Each entry means in the very beginning, element, entries both are same. The element may be 0 or 1. So here we may write it as 0 or otherwise 1. Okay, now in the first year we discussed permutation and combinations. That will come here. The first element can take 0 or 1 in 2 ways. Okay, na? In 2 ways. And means into. And the second element can also take 0 or 1 in 2 ways. Okay, na? And it is not or, and meaning is here also 0, 1. Here also it is 2 ways. In how many this types of two ways. How many terms are there? It is the first element, first term, second term, third term, and going on it is a 9 types are there. 9 types. 9 elements are there. 9 times. 9 times means 2 into 2 into 2 into 2 into 2 into. Okay, na? 4, 4, 2. How many? It is 2 power 9. Will you take? Is it okay now? In the permutation combinations, if two concept is there, and concept is there, it is a multiplication. Or concept that gives addition. Already I gave one example in the first year concept. That is in the same campus, in the same compound, there are 3 theaters, 2 gates are there. The ticket counter is outside that building or that campus, and a man wants to see the same cinema. The same cinema is running in the 3 different theaters and 2 gates are there. You know how many ways? Means a man can enter in the first gate and can enjoy any one of the 3 theaters the same cinema. Otherwise in the second. Like that there, number of gates and number of theaters. 2 into 3, 6. That is a multiplication, fundamental multiplication theorem. Okay now? Like that the first element in 2 ways, the second element 2 ways, and the third element 2 ways, and the fourth, fifth, and sixth, and concept is there. So it is 2 power 9. 2 power 9 means it is 256 is 2 power 8. I am writing here. 2 power 8 into 2. That is 256 into 2. How much? It is 5 always. Okay na? Okay na? So the number of elements, all possible matrices. Okay. About 3 by 3 is 5, 12. Different ways. Okay na? This is the answer. Okay na? Yeah, fast.